Okay, so you will be successful in this lesson for 6.7, the applied problems, if you can say yes to the following statements. I can explain how to solve a right triangle, and I can identify what I know and what I want in a right triangle problem. So first, example 1, to solve a triangle just means to find all the angles and sides. So we're going to use alpha, beta, gamma as our sides in a right triangle. We use the Greek alphabet when we're talking about angles, oftentimes in mathematics. So alpha, beta, gamma, and theta, you'll often see used for angles. So here in this right triangle, alpha we're going to usually think as paired with A, beta is paired with B, and gamma is paired with C. So that means alpha is across from A, beta is across from side B, and angle gamma is across from side C. In this section, gamma will always be the right angle. So if we're given 90 and alpha and B, so if we're given 90 and alpha and B, well then what do we do? So if we're given 90 and alpha and B, and I want to, for example, find beta, well, I know if I want to find beta, I know that alpha plus beta plus gamma must equal 180. So when I take this plus beta plus 90, I can solve for beta and get 56. So at that point, I'd know all my angles and B. From there, I can find A because I know that for alpha, the tangent of alpha is its opposite over its adjacent. So opposite is A that I want to know, and adjacent is B that I was given. Here I'm marking the givens in orange. So if the tangent of alpha is A over B, then the tangent of 34 is A over 10.5. That means that A is going to end up being the tangent of 34 degrees times 10.5. And that gives you that A is approximately equal to 7.08. Then over here to find C, I know alpha and I know beta, and I know B, and I want to find C. Well, if the cosine of alpha, if that's what you look at, that can help us relate the opposite to the hypotenuse, which is what we want. So, the adjacent to the hypotenuse, my bad. So cosine is adjacent over hypotenuse. That's going to give us this B over C, where again, B is something that we know and C is what we want. So when we fill in 10.5 is the adjacent that we know, cosine of 34, I now can solve for C. I multiply both sides by C, these cancel out, I get this. And then if you divide by the cosine of 34, you get this. And so in your calculator, you get 12.67. And now you have successfully solved the entire triangle because you know all of the angle side pairs. Come down here. Again, we're trying to solve ABC. This triangle, well, they're given 90. So we're given 90. We're also given alpha, A, and B. So I'll mark those in green so it's really clear what we were originally given. So if I want to find C, I can use the Pythagorean theorem because I'm assuming it's a right triangle. I'm given that. Okay, so I can find C. Then if I want to find alpha, well, how does alpha relate to my known? Alpha that I want related to my known. So here what I was actually given was A, B, and gamma, to be clear. My bad. And so if I want to know alpha, and I know A and B, then I can write this angle to its opposite and adjacent, and that would be tangent. So I write down the formula, plug in A and B, and now I get that the tangent of alpha is this number. Well, if you have an angle and you take the tangent of an angle, you get a number. If you know that the tangent of angle is equal to this number, you can get back to your original angle by taking the arctan of the number. That's like undoing tangent, also called the inverse function. So if the tangent of alpha is this number, then your alpha is just the arctan of that number. It's on our calculator. We get 21.27. Really make sure that your calculator is in degrees. Really be careful that it's undue tangent. It is not 1 over tangent. No, 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 no. So, although you will see it written this way, it is not 1 over tangent. No. That's why I don't write it this way. That's why I choose to write it as arctan. Then for applied problems, if you look out into the world and you have the horizontal and you open up an angle from the horizontal to look up at an object like a bird, we call that the angle of elevation. It's always from the horizontal. If we have a horizontal line and we look down, that is called an angle of depression. So we always think about elevating up from a horizontal or depressing down from a horizontal. Everything is from the horizontal. So in this case, if we've got a point 15 meters above level ground, a surveyor measures an angle of depression from the object or an angle of depression, to an object on the ground. So the surveyor is chilling out up here. He looks out at the horizontal and opens down an angle of depression of 68 degrees to this object here. So this is my object here. Well, since that's my angle of depression, since these are parallel, I know parallel lines cut by a transversal that alternate interior angles are congruent. So if that's 68, this is also 68. And since I assume that the ground is nice and level and I'm straight above it, this is a right triangle. And so there's 22 degrees left because all angles must add up to 180 in our triangle. So now if I want to know this distance, what's the distance from the object to the point on the ground directly beneath the surveyor? So in other words, what's the distance from here to here? Well, that's D. I know this is 15 and that's 68 degrees. Well, the opposite over adjacent would be the tangent of 68 degrees. So then I multiply both sides by D, and then divide both sides by tangent of 68, and we get whatever this is in meters. And it turns out that in meters, that's about 6.06 meters. Here, we're talking about directions and bearings. The main thing to think here is you can really only go north or south most of the time. You just adjust your direction away from the vertical axis by opening up some east or some west angle. So for example, to get from P to Q, you're going north, but you screwed up a little bit and you opened up 25 degrees east. So the bearing from P to Q1 is north 25 degrees east. The bearing from P to Q2, I was trying to go north, but I screwed up and went a little west. I actually went 70 degrees west. So this direction is I was going north, but then opened 70 degrees west. Okay, and you can see the other two there. Where now I'm going south, but then I screwed up a little bit and opened up 40 degrees west to get from P to Q3. Then I went south and screwed up 55 degrees east to get my bearing from P to Q4, which is south 55 degrees east. Okay, let me see. I was trying to see this one, and okay. So, if I have this sort of a picture, so two ships leave a port. So I've got my port right here, and one is going north, but it opens up 23 degrees east. Let me see if this picture is any better. Yeah, maybe that one's better. So it goes north, but 23 degrees east, right? The other ship goes south, but screws up and goes 67 degrees east. So it would be going this way. So there's our first ship A and our next ship B. We've got a distance between them. Well, first, I want to approximate the bearing from the second ship back to the first 1 hour later. Well, first it tells us that the first ship is going 11 miles an hour. So after 1 hour, this is 11 miles. And then it says after 1 hour, this ship is going 15 miles an hour. So after 1 hour, this ship has gone 15 miles. So let's see. If this opens up 23 degrees, and this opens 27 degrees, then we know that there's 90 degrees left over for this angle right here, because this is a straight angle and this entire thing must sum to 180. So 23 plus something plus 67 equals to 180. That means that something must have been 90, and that's our angle here. Okay, well then I can actually, if I do a little bit more work, this would be a nice 90-degree angle right here, yes? If I go from, I'm going to make a bearing at B and a bearing at my port. That would make two nice parallel lines. So this is a nice right angle between those two bearings, between those two little crosses. So this is 67, this is 90 degrees, and if this is 67, then that means there must be 23 degrees left over here, yes? And so if this is 23 degrees, then that means that alpha right here what was that? Why did I get? Okay. Well, I'm going to worry about alpha in just 1 second. So this must be 23 degrees, yes? So if this is 67 and this is 90, this little piece is 23. Well, then to find alpha, and the reason I want to find it is because my bearing from this ship to that ship is going to be, I went north, right? And then I opened up some little angle over here. So the way I'm going to find this angle is I'm going to take this plus this and subtract it from 90, right? So if that's 23, to find alpha, I know that since this is a right triangle, the opposite over adjacent is going to be the tangent. So the tangent of alpha is the opposite over adjacent. So if tangent of alpha is 11 over 15, then to get back to alpha, I take the arctan of the number to get back to the angle. So alpha is 36.25. So now I know that this plus beta has got to equal 90. And so when I solve for beta, I get that beta is 30.75. That means that my bearing was north, but I went 30.75 east to get to that other ship, right? So what I wanted the bearing from B to A. So notice when we were thinking about what do we know and what do we want, so much of the what do I know is wrapped up in the picture, and so much of what I want is really making sure we understand that last little piece. So that's it. Thank you.